So now let's learn multiplication of vector using vector product. When we talk about vector product, our vector product is A sine theta, and we also call this cross product. So that means A cross B. That is the way we say it. The earlier one we did was scalar product or dot product. We call it A dot B. So what we should know is that our important formula is A cross B is equals to A B sine theta, please. So it's going to be A cross B is equals to, so our is going to AB cos theta. So in other words, that is AB sine theta. So when we have our A cross B to be 0, what that means is that A and B are parallel. That's why we have 0. So but if they are perpendicular, it can never be 0. How do we obtain the direction of the cross product of A cross B? We obtain that using our right hand rule. So what does our right hand rule indicate? Suppose my vector A is pointing towards this direction and my vector B is towards this direction. If I should get my right hand rule for A cross B, I am going to place my right finger along A. And I make my finger facing B, then I'm going to curve it towards B. Then my thumb pointing up is my direction of A cross B. And that is the method of right hand rule. Okay, let's consider another scenario. What if I want to get B cross A? Using the same rule, for my B, I'm going to place my finger or my forefinger along B. But if I'm to get my finger along B and to curl it towards A, I cannot use my back hand. So that means I am going to point my finger down. My thumb facing down, I can be able to get my forefingers towards B. Then I can then curve it towards A to get my B cross A. So that means the direction is downward. So we can therefore say that A cross B is the same as B cross A, but this one with minus. So they are anti-commutative. You remember earlier that we said the dot product of two vectors are commutative. That is, A dot B is the same thing as B dot A. But for the cross product of vectors, A cross B is equals to minus B cross A. So another thing we should understand is that how does this vector product affect our unit vector? So when we have I cross I or J cross J or K cross K, all of these will give us 0. Because why? We said I cross I is the same thing as AB sine theta. And we said that I cross I has no angle. So that means theta is 0. So when we have AB sine 0, that is II sine 0 is going to give us 0. And that is the reason why it is 0. However, if we have I cross J, using our right hand rule on this formula, we are going to obtain our direction along K. And when we have J cross K, we are going to get our direction along I. And when we have K cross I, our direction will be along J. And we have learned that cross product of two vectors is anti-commutative, meaning that I cross K will give us the reverse, which is minus. And K cross J will give us minus. And I cross J will give us minus J cross I. So how do we use our right hand rules? Let's say, for example, I want to get my I cross J. So what do? I'm going to place my four fingers along I. And for me to be able to sweep towards J, that means I need to point down. So if I point down, I'm going to be sweeping towards K, so that means I have to point up with my right finger pointing towards my X axis, or my forefinger point, then I can sweep towards J, and that is going to give me I cross J, and my index finger is going to be pointing up, which is going to be along K, along my Z component, and I can repeat the same step for J cross K. I'm putting on my forefinger along my J, then I sweep towards K, then my thumb represents the direction. So you need to commit this to your memory for you to resolve vector product. So now our task right now is to find the cross product of vector A and B having components along X, Y, and Z. So how do we do that? Okay, so let's do that on our whiteboard marker. So now our goal now is to apply our vector product, and to make it more easier, let's keep this at this edge. We'll make use of it later on. So now let's find vector A cross B. So to do that, we do our expansion, which is going to be A times B. So we are going to have AX, BX, then we have I cross, this time around is I cross I. And we are going to have the same, we are going to have AX, BY, and at the same time we are going to have I cross J. And at the same time, we are going to have AX, BZ, okay? So we have AX, BZ, and our unit vector is going to be I cross K. So we have I cross K. Then we plus. Then the next we are going to have is going to be AY multiplied by BX. So we have AY multiplied by BX, and the unit vector is going to be J cross I. So we have J cross I. Okay. Then the next one is going to be AY multiplied by BY. So we have AY multiplied by BY with the unit vector going to be J cross J. Plus we are going to have AY multiplied by BZ. So we have AY multiplied by BZ, and the unit vector is going to be J cross K. Then we continue that way. We are going to have AZ multiplied by BX. So we have BX, and the unit vector becomes K cross I. Okay? Plus we have AZ multiplied by BY, and the unit vector is K cross J. So then lastly, we are going to have AZ multiplied by BZ, and the component is K cross K. Don't forget that we said that I cross I is the same thing as K cross K, and is the same thing as J cross J, and everything equals to 0, because sine 90 is 0, because we said AB sine theta is equals to A cross B. So when we have I times I is equals to sine 90 degrees, and sine 90 is 0. So we can continue and apply this relation. So when we said I, so let me use the right pen to strike out what we don't need. I cross I is 0, and J cross J is 0, and also K cross K is also 0. So we are left with AX and BY. So we have 0 here so that we don't miss anything. plus ax by, and what is I cross j? Let's look at our relation here. I cross j is equals to k. So we have k here. Then plus, what is ax bx? I cross k, which is equals to minus j. So that means we can't have plus here. So we are going to have minus here because of I cross k. K cross I is j. So therefore this becomes ax bz, then we have j. So let me explain again. We have our ax bz, but our I k is equals to j minus k, because this is what we have. Alright, so this becomes minus j. So we are done with these two. So let's move on to this term, the fourth one. Then we have plus. So we have ay bx. Then let's look at our relation when we have j cross I. That is minus k, because I cross j is k, then j cross I is minus k. So therefore, we cannot have positive here. So we're going to have minus. We are going to have minus k here for j cross I. So we are done with this. Then let's look at this. We have 0. Then we also have ay bz. But when we have j cross k, is going to be positive I. So we have our positive here and we have I. So we are done with this j cross k. Then we can continue. We have az bx, and k cross I is j. From here, k cross I is j. How about az by? So we have az by. But what is k cross j? Let's look at our relation. K cross j is minus I. It's only j cross k that is I, but we now need k cross j becomes minus I. So we have minus I. Okay? Let's put in our cap. So we have k cross j here. Then the last one, we have 0. So we expect us to have a complete number here. Okay? Now, if everything being equal, we can collect the like times. Let's start with I component. Can we identify all the i's? So we have this one and this one. So therefore, we can write ay bz, that is for this, minus az by. And that gives me my I component. Okay? Then let's look at plus. Let's look at my k component. So can we find k component? For k component, we have this and this. So we start with ax by minus ay bx, and we have our k component. Then let's have our final value, which is our j. Let's look for our j. We have this one and this one. So let's start with the positive. So we have az and bx minus ax and bz. And this gives us our j component. So this is what it looks like to find the cross product of two vectors. But this is not the only way. We can also use determinants to find the cross product of two vectors. Okay? So this is our vector again. And this time around, Let's say we have A cross B. So now we want to use determinant to obtain our cross product. So what do we mean by that? We have our I, this is my I have my J, I have my K, okay, and my AX is here, AY is here, and AZ is here. I have my BX, my BY, and BZ. So for me to get that, the rule is that, so I'm going to first cover this, and I'll be left with this matrix, which is AY, AZ, and BY, and BZ, okay, to represent my I component. Then the next part is, you should understand this is positive, negative, and positive. So for that reason, this one is going to be negative, alright? So we are going to cover this part, okay, so that we are left with just what is at the edge, okay? We now have AX and AZ, then we have BX and BZ. This for our J component, okay? Then for the third determinant, we are going to cover this part, okay, and we are left with this determinant, which is AX, AY, BX, and BY. So now we can, and this is our K component. So if we resolve, this comes first before this, okay? So we are going to have AY and BZ minus BY, or let's put A first. So we have AZ, BY, and this for our I component. And for this, we have our J. So like I said, we have this first before this. So we have AX and BZ. Then we have minus AZBX, okay? And for our K component, we have this, which is going to be AX and BY minus, for this one now we have AY and this is my Y and BX. Now if you compare this one with this, except very small difference, isn't it? That is, if you can observe it. Can you observe it? Did I wait? The difference exists here. So here we have our AY, we have our AYBZ minus AZ. Everything here is the same. Everything here is the same. So what did we miss here? AXBY, we have AX, we have AZBX minus AXBZ. So here we have AXBY, we have AXBY minus AYBX minus AY. So this is also the same. But what is different is this third component. So what happened? This is positive, this is negative. This is negative, this is negative. So let's do the right thing. This is mathematics. So let's do it together. So we have our I component, we rewrite AY, we have BZ minus AZ, BY, okay, nothing changed. In place of our minus, if we put plus, what will happen to our matrix? If we put plus, that means this becomes positive and this becomes negative. That means it's like we multiply it by minus, which is a normal equation. So if you want to understand, let's say I have minus 3 minus 9. It's the same as opening up the bracket to be 9 minus 3. That is what it means. Because minus times positive 3 becomes minus 3, and minus times minus becomes positive 9. So it's the same thing as minus 3 plus 9, which is the same thing as 9 minus 3. So what we have here is minus, multiplying this becomes minus ax bz, and this becomes positive az bx. So instead of writing minus ax bz positive az bx, we can write the positive to be at the front and the negative after the expansion of the sign to be at the back. Then we have this as follows. So everything becomes ax by minus ay bx. So we have this just the same way we have that. Correct? So that is how we get it. Our components all accounted for. This is our I, this is our I, this for our k, this for our k, and this is our j, and this for our j. All components accounted for using different methods. So if you truly understand this, your goal now is to solve a problem, then we wrap it up. Okay? So now we have an example. So how do we solve it? So we can find the cross product of these two vectors, a cross b. These are vectors a and b, which is going to be the determinant of 5 minus 7 and 3. This is my I, j, and k. And for my b, we have minus 4 plus 7 minus 8. And you remember what I said? We are going to cover this side, and we are left with our determinant, which is minus 7, 3, 7, and 8. Now we are going to cover this. So just see this, that I'm covering it, and I have my minus. Don't forget it's positive, minus, positive. So I have my minus here, then I have my j. Okay. Then what am I having? I have 5, 3, minus 4, and minus 8. So I have 5, 3, minus 4, and minus 8. So and for the last one, so now we are going to cover this side. So we are left with positive k, which is our 5. That is this, minus 7, minus 4, and 7. So I don't need to add positive, just 7. Okay? So now that we have this, we can have our matrix again, which is going to be minus 8, so that we can cross-reference. So now we have our positive, negative here. So if we do this, we have minus 7 times 8, and we have 3 times 7 to give us our I. Then we have minus. Then we have 5 times minus 8. Then we also have 3 times minus 4 to give our k. Then we have also 5 times 7. And we also have minus 4 times minus 7 to give our, this is our j component, that is this one, and this is our k component. So what do we have? 7 multiplied by 8 going to give us 56. So we have I equals to minus 56 times 3 times 7, that is 21. Okay? And minus, so let's put this big minus out. 5 times 8 is going to be 40, and times 3 times minus 4 that is going to be minus 12. And this is our j, and this is going to be 5 times 7 is going to be 35 times minus 4 times 7, that is 28, and everything k. So we are getting closer. So finally, we can have minus 56 times 21. So something is missing here, and who can identify it? Something is missing, and it's very important we fix it. Something is missing here. So you remember, so let's represent that with black. So when I said 7 multiplied by minus 8, then 7 times 3, I'm supposed to put minus there. So this is supposed to be minus. Okay? And whenever I said 5 times minus 8, okay, then there's supposed to be minus here times 3 times minus 4. So there, here I have minus. So sorry for the error. Then here, when I said 5 multiplied by 7, 5 multiplied by 7, supposed to be minus 4 times 7. So 4 times 7, then we have a very big bracket to represent our k here, just like this one too. So I hope this is very clear. So at the end of the day, what we are left with is 5 times 7, that is 35, and we have our minus here, and this gives us 28. So we can remove this bracket. So we are right, and write 28. So what is minus 56 times 25? We have 56 minus 21. So we have minus 35. So here we have minus 35. Then we have minus 40 and minus 12. This is the same thing as minus 40 and 12. 40 minus 12. So we have 28. Okay? 28j. That is for our j component. Now let's look at our k component. We have 5 times 7 minus 4 minus 7. So which is minus 4 times minus 7. So we have our minus here. 5 times 7 is 35. Minus 4 minus 7 becomes minus 28. So when you find 35 minus 28, so we have 7. So here we have 7k. So our answer becomes A cross B equals to minus 35 minus 28j plus 7k. So if you understand this, then you can understand the multiplication of vectors of different components. And with that, this brings us to the end of module 1. For our next module, we shall be treating kinematics, which has to do with the physics of the motion of objects without considering the force that causes them. We shall deal with motion along 1 dimension, 2 dimension, and 3 dimension plane. So I hope to see you in our next video. Thank you. Bye bye.